Now we will discuss the chemical reactions which will be due to the cleavage of the ROH bond, and we have discussed about the reactivity of these reactions in our previous video and the acidity and explanation of acidity of alcohols in our previous video. And now we'll take the reactions that come under this category. First is the reaction with metals or the acidity of alcohols or acidic nature of alcohols. We know that alcohols, when they react with some active metal, they release oxygen forming the alkoxides, and this shows their acidic nature. And we have already discussed that they are weaker acids and even weaker than the water because they have the alkyl group attached to them, which is electron releasing, and this is the reason why primary are more acidic than secondary alcohols, which are more acidic than the tertiary alcohols. This we have already discussed in our previous video. You can see that. Second type of reaction which come in this category is the reaction with the Grignard reagent. With Grignard reagent, the alcohols react to form the alkanes. This is your alcohol and this is your Grignard reagent. They will react to give the alkane RH with ROMGX. And third reaction is a reaction with organic acids, and when this reaction is carried out in the presence of HCl, we call it esterification. And this is this reaction CH3 C double bond O reaction with acids. CH3 C double bond OH. This is your acetic acid. This when reacts with C2H5OH, that is with ethanol, it will, in the presence of HCl, it will give CH3 COO C2H5 and with liberation of the water. And now let's see the mechanism of this reaction. This reaction is also called Fischer-Spire esterification. Now we will see the mechanism of this reaction. This is your acid. Protons from acid, and in the presence of these protons, what will happen? They will be attracted towards oxygen, which have more electronegativity, so it has more electron density near it, and they will come and sit near this oxygen, and then due to which this carbon bond will be attracted towards oxygen, and this becomes positive, and the ROH, that is molecule of water, molecule of alcohol will be attracted towards this, and we get RCOH and ORH. Now this oxygen will become positive, and now here will be proton shift, and we get R C OH OR dash OH and H, due to which this oxygen will become positive and this bond will be broken up to liberate the water molecule, and water molecule will be given up, and we get RCOH OR dash. This carbon will be with the positive charge as oxygen has taken away electron. So this will be positively charged, and what will happen? This bond will be shifted towards this with the release of the proton. Proton will be released, and we get RC double bond O OR dash. This is your ester, and the reaction is called the Fischer-Spire esterification. The other reaction which will come under this category will be the reaction with the acid chloride, will be the reaction with acid chlorides and the acid anhydrides. Let's see that. First is the reaction with the acid chloride. With acid chloride, and CS3CO, or we can say RCOCl, RCOCl when reacts with the alcohol, it will form RCOOR, that is again ester with formation of HCl. Let's discuss it. And now the mechanism of this reaction. This is your acid chloride. This when react with alcohol. We know it's the nature of carbonyl group that in the presence of the nucleophile, this bond will be given up to the oxygen and carbon will become with somewhat positive charge. So this will come and sit over here. This nucleophile will be attracted towards this carbon for the we can say that this carbon is made available for the nucleophilic attack. And we get this RCO negative 1 2 3 4 5 6 Cl and OR and H. This oxygen now will become positive, and this bond will be broken up, and this will come back, and in this we get Cl will be given up, Cl negative, and RC double bond O R and H. So when this is positive, this bond will be given towards this, and proton will be released. We get RC double bond O R. This is the mechanism of the reaction with the acid chloride, in which again we got ester. And now is the reaction with acid anhydride. Look how. This is your acid anhydride, reaction with acid anhydride. RC, or we can write it like this. Example is CS3CO, CS3CO. This is your acetic anhydride. When this going to react with alcohol, it's going to form CS3COO C2H5 with formation of CS3COH. Now see the mechanism of this reaction. Here again esters are formed. Let's take in general RCO, C double bond O R. This is your acetic anhydride or any anhydride, acid anhydride. This acid anhydride reacts with alcohol. Now, we have already said that it is the nature of the carbonyl group when in the presence of nucleophile, this bond pair is taken by oxygen, making the carbon positive. So it is best for the nucleophile to attack over here. So this has seen in the previous reaction also. Now let's see this. We got this oxygen with 6 electrons and negative charge, and here ORH, this is positive, and R, we got this. Now what will happen is this will come back over here to neutralize this oxygen positive charge, and this bond will be broken up over here. When this will be broken up, we got RCOO negative, this will be liberated out, and now we get RC double bond O, and we have ORH, this oxygen is with positive charge. Now what will happen is this bond again be broken up, giving electrons to the oxygen and liberating the proton. Now we are going to get RC double bond O R. This is your ester. This is your ester which is formed. So these were some of the reactions that came under the category of these reactions, that was because of the cleavage of the OH bond. So that's all for this video.